Alright, for this next graph we're going to be looking at comparing the function f of x equal x squared to another new function g of x equals x minus 3 quantity squared. So in the last example we added a 2 on the outside after the square. Here we're going to be subtracting a 3 on the inside before the square. Okay, it's a different operation, but it's really the location of the operation that's important. Instead of being on the outside being added to the square, it's on the inside before the square is taken place. Okay, so I'm going to go through a xy table again, just like we did in the last example. I'm going to substitute 0 in for the x squared. I'm going to get 0. Substitute, however, if I substitute that same 0 in for the g of x, we're going to get 0 minus 3, which is negative 3. Square negative 3, you're going to get 9. Okay. Next is the number 1. Well, square 1, you get 1. However, if you plug the 1 in to g of x, you get g of 1 is 1 minus 3, which is negative 2. Square the negative 2 and you get 4. Okay. Now if we go with a 2, plug the 2 in, 2 squared is 4. On the next one, if I plug that same 2 into the g of x, I get 2 minus 3 is negative 1, and negative 1 squared is 1. Now we plug in the 3. 3 squared is, of course, 9. And plug in the 3 here. 3 minus 3 is 0. 0 squared is 0. Okay, so for these first 4 points, you might notice something a little bit odd. This one goes from 0 to 9, this one goes from 9 to 0. They're in kind of reverse order. Okay, we know that these positive values of x are the part of the parabola going up to the right. It's the right half of the parabola. And that's evidenced by these numbers, these outputs, 0, 1, 4, 9. So it's an increase going up to the right. Here, however, we actually have a decrease going down to 0 from 9. So you start up high and you come down. So it must be the left half of the graph. And so I guess the question would be, what happens if we continue to go further right? Okay, so if this is the left half where it comes down to 0, let's try a few more numbers instead of going to the negatives, because I think if we plug negatives in, you'll find that it just continues to get bigger and bigger. These numbers will just, become 16, 25, and so on. So we're going to go the other way. We're going to go with 4 and 5, and maybe I'll throw 6 in there as well. Alright, so start with a 4. Well, 4 squared is 16. We're not going to be plotting that on the graph probably. But plug the 4 into the g of x, you get 4 minus 3 is 1. 1 squared is 1. Okay. If I plug the 5 in, 5 squared is 25. But if I plug the 5 into the g of x, 5 minus 3 is 2. 2 squared is 4. And then here finally the 6, plug the 6 in, 6 squared is 36. But if I plug the 6 in here, 6 minus 3 is 3, squared you get 9. And so now I'm seeing this symmetrical pattern on the right, but on the left it just keeps increasing, increasing, increasing. Okay. So now let's take a quick look at the sketch of the graph. So I'm going to plot the graph of that first graph, the same one we did, the f of x. That's the same one we did in the last couple videos, so I can sketch those out pretty quickly. Bad. Okay, so now I'm going to add in this g of x function. So if I go 0, comma 9, so there's 0, 9 is going to be right up here. Then I've got 1, comma 4, so here's 1, up 4. And then 2, comma 1, so over 2, up 1. 3, comma 0 is a really important point. And then we got 4, 1. And then 5, 4. And then 6 goes up to 9. You can probably already see what's going on. If I were to sketch the graph then, what you'll see as I sketch this graph is that the new graph is a shift of the old graph to the right 3 units. Okay, so if you just kind of take a look at this, each point on the original graph moved over 3 units to the right. Okay, every point. This point here moves over 3. This point, let's see, what was the other one up here? 16, that one moved over 3. All of these points are moving over exactly 3 units to the right. Okay. So that means what we've done is we've shifted the graph to the right 3 units. Now how do I know 3 other than by the graph? Well, the 3 happens to show up in the g of x equation. What's interesting is that we're moving this graph horizontally now. And remember the last example we moved it vertically. But when we do a horizontal movement, what we're doing is we're trying to find the value you would have to plug in to zero out the function. And so by plugging a 3 in, which is the opposite of this number, right, the minus 3, that gives you the 0 output, and 0 squared is 0. Alright, so that should help to clue you in as to why this negative 3 is different than what's here as a positive 3. Alright, so let's look at a couple things. First of all, the vertex. That's at a very important point. That is at the point 3, comma 0. Okay. This graph is shifted horizontally to the right 3 units. As a general rule, in general, y equals x minus h squared is a horizontal shift of x squared by h units. I suppose we use h because it's a horizontal shift. Okay. Now when this h value is positive, the x minus h will have a minus in there. Okay, so that's kind of weird. So let's give a concrete example here. If we had h equals 5, for instance, then y equals x minus 5 squared is a horizontal shift right 5. Notice that my h value is the shift, but the h value has opposite sign of what's in the parentheses. Whoa, gotta move that up. Okay. H value is 5, it's positive. That gives you the right shift 5, but it's the opposite sign of what's in the parentheses. The h is actually what you're plugging in. What you're plugging in here for this h, and then using the negative on it. Okay. A couple other things in general to keep in mind is that the vertex is going to be h comma 0, because in this situation, if you were to shift from 0, 0, right H, or left, doesn't matter, whatever, then you're going to have from 0, 0, you're going to have H0 as your new vertex. So you just add the H to the 0. Okay. The other thing to keep in mind is that you can get a left shift by making this negative, right? So if H equals a -7, then Y equals X. Now it would be a minus -7, which changes the sign to a plus. That is a shift left 7.